Okay, well, it is November 17th. It is Tuesday, and it is year 2020. Why do I mention this? Well, we just have 2020 AMC 8 finished, right? So the time window just closed, and now we would like to kick off the analysis. So if you have your memory really fresh, follow me. We will have some news and some feedback, some trends to talk about. All right, so this is the first half. And on Friday, we'll have the second half, talking about those challenge questions where if there's a transition, how can I prepare for AMC 10? So there's a lot to share. However, for time consideration, maybe it's kind of too long to play the whole game. All right, so this is the first half we have. Let's go. Well, first things first. About me. Well, if you know me, this is just a review. And if not very familiar, hey, my name is YiXian and I love math. Well, I am from Think Academy and I have taught about AMC 8, AMC 10, and I have MCTP course, which aims or is a target for Amy. So we have studied a lot about the past problems, and for this year, as we have broadcast yesterday, we have studied these questions. Well, I tried to write down those solutions, and we'll see along this year, what is the trend, what is a characteristic, what is the difference in between this year and past years? Well, maybe that's the topic next time. Well, what is AMC 8? Oh, especially for 2020. Again, we have 25 questions. If you have taken it, of course, you should know it. This is what you know, and we have 40 minutes. And what about the time window? The time window is from November 10th to November 16th. Well, usually we'll call the Tuesday, but sometimes it is not perfectly just one day. Well, it depends. We will have some sort of time window so that if you don't have time specifically sharp that time, you can have it sometime later, but it won't last very long. And for this year, we have 475 students registered with Think Academy. While if you want to give a shot with AMC 10, we have all those spots open for you. Well, later contact me. I'll have those set up. Well, we're running for that. We have 10A and 10B. Well, a very special case for this year is that due to COVID-19, it is online. Well, up to my memory, for past years, mostly they were held offline. So they will have those printouts sent to schools so that a classroom or maybe a hall would be taken for this. And what about the following procedure? Like if you do this with Think Academy, what are you expecting? Well, if you do register with us, then we will get back to you as soon as possible. Well, apparently we don't do the scoring at this moment. It's online. So as long as we get this from MAA or from the organizer, we will get back to you through individual emails with your achievements and scores as soon as possible, I assure you. What about next level? Well, if this is your first chance where maybe you say, I'm still very young, yes, next year you can take another chance for AMC 8. Or if you say, I'm kind of ready, I want to move forward, I want to know what is the next level. We have not only AMC 8, of course, we have AMC 10, and there is AMC 12, and some other level competitions. Well, if you like, next time we'll break it up and introduce them again. So far, we have our AMC 10 short-term course and MCTP course. If you plan to take AMC 10, well, 10A and 10B are held next February, early February. So we have around 3 months, not full, but sort of. So this is a chance for you to take a look at it, and also we can help you register for that. So it is a good chance to try it. And also we have an even higher level course for that, which is MCTP. So that aims targets for Amy, as I mentioned before. Well, let's see. For this year, a very interesting thing is that we should have more and more students participating. Well, for past years, it should be the trend. Well, this is the 2019 data, of course. Well, why do I say so? On one hand, we have this pandemic. On the other hand, it is fall, winter, so it is the season for us to study and to stay healthy, to stay safe. Maybe it's kind of a better idea to get back home and study math. Of course, there are so many subjects. So this one is the data we have for 2019, and we see it's it's actually 94,000 students. So if we expect, say, 5% or maybe 10, even higher, 15% for participants, for students, maybe we'll have like 100,000 or even higher. We may have a call. Well, along this curve, you will see actually some of the students taking are just trying. So the peak is around, what is that? We have 7 or 8. So if you have that better than 7 or 8, actually you're doing really good. And we have honor roll as well as distinguished honor roll. About prediction or some guesses. Well, I tried those questions for this year as well. Hard to say, but for the difficulties, actually, they are not as hard as past 2 years, I should say. There are not so many tools. However, later I will mention there are some trends. There are something not very similar this year. So I would expect that to be kind of higher comparing to the past years, but not too high, the distance. So let's see, what about this year? Well, talking about last year doesn't contribute too much, isn't it? Well, what is a concentration? Well, we do have some modules where some other ways to categorize all those questions, of course. So those are made up by people. So typically we have these kind of study with math teachers, of course. And those 4, the reason I put those in these 4 is that this is a more traditional way we have for a secondary school mathematics. So typically when you study for numbers, operations, and sometimes when you say word problem, of course, most of those are based on algebra. Because we want to set up equations, we want to know what is a relation. Maybe we need some unknown or we need some techniques to find the solution. And that's why I combine all of these back. And it is quite different comparing to the past years, is that we notice geometry, number theory, and combinatorics are really less than before. Why? Do you have the answer? Well, at least you can make a guess. For the trend, or say characteristics, well, we have those pie chart. We see algebra takes more than 50% actually, and we only have 2 number theory questions. However, that doesn't mean those few parts are less weighted. Actually, you may feel number 17 and number 19, those 2 number theory questions are kind of weird or kind of tricky. It takes a little time to think about how should we start. And I'll call about 3 major trends for this year, and the 4th one I put in parentheses. You may take it or not, it is optional. So first, about algebra, it is algebra focused. Well, if we take it back to numbers and operations, of course, most of the questions are in that category, and some are word problems, of course. But for word problems, it is mainly about fractions, about equations, talking about fractions or proportions or percentages or ratios, all those kind of things. And very rare we have motion problems. For this year, we have a graph, but that is almost there. Well, I put 15, 16, and 24 there, is that these 3 are more or less middle school computation. You may recall like that X to Y or something. Well, if we put that in terms of AMC 10 or just all this kind of secondary school, problems, it is not that hard. It is not. But here, if we're not very familiar, this is the very first time we see about equations, about letters. Say problem 16, there are 6 points. 6 points. A, B, C, D, E, F. Each one represents one number. It is kind of challenging. Or you may think of like throwing darts. Remember that? We have a past problem like that. And also we have something like putting that slip into different containers. So we have these kind of problems before, but we can think of that in terms of combinatorics as well. We have a lot of questions in this intersection. So sometimes we may think of a problem in terms of number theory. However, it requires like the counting, which we have. So that is algebra focused. That tells we should focus more about the general tool along math study. So this follows a trend with Common Core. It came out around 10 years ago, and now we want all these courses back to track, back to normal. So we are expecting school courses to be kind of harder than what they were. And what about number theory? Number 2, the point 2 I put there, is that they are not straightforward. Trust me, these two are actually comprehensive. If you can do it, super good, super good. I should say maybe the second one, number 19. It should be like one of the last 5. The last 5 questions are not that hard. Well, sometimes we may say the order shouldn't matter, but maybe. Let's see if we have the official data coming out. Whether or not we have the correctness for that number 19 to be lower than any of the last 5. And what about point 3? Point 3 is that it's more about computation, concentrated. Of course, it is online. Well, this one is not that strong as the first 2. Well, I have one word missing in the first line. I say it's kind of tricky. Well, don't worry, I'll mention that later. I'll put some examples to help illustrate what happens to this here. And also, we have very few geometry questions comparing to the past years. We have around 4. Well, it is a good news, isn't it? Because typically we have those physical printouts, but for this year we don't. So if you take the test, staring at your computer, staring at the screen, and then you will see it is kind of harder to eyeball the answer. Yes, that is the question. So the main reason for this kind of structure, I have to say it is really different than what we have before. But if you really trace it back to, say, before year 2000 or maybe year 1990, somehow we have a lot of such computation or algebra-based questions. Somehow this genre is like that. Well, the main reason is definitely the pandemic. So all of these are turned online. Drawing a plot or say plotting a graph. It's not that easy. That's one from the problem writing side. And from the other side, if you have it on your screen, how can you make those auxiliary lines? How can you mark all those components? Remember, we only allow rulers. Besides erasers, but besides pens or pencils. So that's what I said, less physical printout. The support is not as strong as before. And I have one last question here. How is your draft? Well, typically, when we get it back to algebra, when we get it back to computation, it requires a good habit of your computation. So did you do a really good draft? Well, let's hold that for now and see some kind of questions here. Well, this is problem 7. It is combinatorics, of course. It is counting. And also, it is algebra based. Definitely, we want to see what happens to these numbers, and we want to have those 4 operations. So it says how many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order. Well, increasing. We have the 1000 digit fixed, so there's no change. And what about hundreds digit? Is this supposed to be 0? No, it's not increasing. So the immediate number after 2, consecutive number, is 3. And could it be 4? If it is 4, 2400, there's no upcoming numbers. So it has to be 3. 23 something, 2300 and something. That means if we see this, if we make this jump, this is number 7, so it shouldn't be that hard. Of course, I trust you, you get it. Then we will know, I only need to determine how many different numbers, how many different combinations are there on the back, on the last 2 digits. We only need to select it from like 4 to 9. Pick 2. Pick 2 and it's done, because the smaller one will be the tens digit and the larger one will be the unit digit. Just that. So if we see how tricky it is, then it becomes not very hard. By the way, I count it in terms of difficulty 1, because it is kind of straightforward, although kind of tricky in the mind setting. Still, it's not hard. It's not challenging. What about next one? Well, next one, computation is still not hard, but we need to work on those words. We need to be careful on those language. Well, 2020 coins, either penny or nickel. So 1 cent or 5 cents. At least 1 penny, at least 1 nickel. That means we can just take 2, like 1 from each, and throw them away, because after all, they are not changing. And what is the difference between the greatest value and the least value? Well, first, what I put there is that you can think of like 2019 and one of these. That's our intuition. Or maybe if you're smarter than I am, then you can think of, oh, actually, it is the difference with 2018 coins. Exactly. What is the difference in between those greatest and least values? So actually, that is the reason I say it's tricky, but it's not that hard. Again, the difficulty for this problem, 1 star. What about next? Well, this one, it's one of the geometry questions. Well, does that look familiar? We have a lot of such questions. A cube, you paint it, you cut it, and then you count like how many cubes, how many units are of a specific characteristic. Yes, exactly. So let's think of this. We have a birthday cake, which is 4 by 4 by 4. Well, I didn't have it. I didn't have such a birthday cake, like 4 by 4 by 4 in a cube. Usually I have all this like a circular, or say a cylinder shape. Well, the cake has icing. Well, that tastes sweet on the top and 4 side faces. So no icing on the bottom. Well, typically no icing for any kind of such cakes. Well, if you have, that's really rare. Suppose the cake is cut into 64. Well, if we're not told that, we should be able to find it. It's 4 by 4 by 4 or 4 cubed. My calculation. And then each measuring 1 by 1 by 1, or we can say they're of equivalent sizes. How many of the small pieces have exactly 2 sides with the icing? Well, that refers back to our study with respect to surface area. Yes. What do I mean by surface area? It means if I consider for those components, like for all those small cubes, how many faces are there for each one? If I count, does it have to contribute for the whole surface area? Well, one observation, for example, the corner pointing towards us, the very one in the center. Well, it represents one of the corner on the top, and actually it represents the same for the other three. We have three sides, top and two side faces. So actually for each one of these four small cubes, we have three faces with icing. That is one category. Well, also we know there are some cubes without icing. That is in the kernel. However, here it is kind of tricky. It's not like 2 by 2 by 2, but actually it is 2 by 2 by 3. So the whole center will be non-iced. What about one face? What about all these units with exactly one face with icing? Well, typically we may think of those in terms of the centers of each phase. It's more like a 2 by 2 for each phase. And by the way, how many faces are there for a cube? 6, right? 6. And here we have 2 by 2, so 24 with that? Not really. Not really, because the bottom face, there's no icing. So if you think of this first, the center of the bottom face, it is no icing. And what about those the bottom sides? Well, the center two pieces on the bottom sides are also with one side with icing. So think of the side faces. We have only middle part with exactly one side pointing outward. So then, that tells us what happens to exactly two faces with icing. We notice that besides the corner, anyone on that edge, like the middle on top, or besides the very top one, all the other three on bottom of it, will be considered, isn't it? Think of that for a moment. Close your eyes. We have two faces right on the edge. If it is not on the corner, then we know it doesn't touch the top. However, for bottom, it's kind of special, so we count all of those four. And now if we see that, we will see what is accounting. For example, we have 3 on those side edges, hence we have 4 times 3, which is 12, and then we have 2 on each of the top, hence we have 8 there. Together we have 20. Do you get it? Well, if you think of that with a bottom face, all with icing, then you will have a 24. So my prediction for this one, for example, is that we have a lot of students picking 24. Tell me if you don't. All right. What about next one? Well, this one is one question I want to introduce because I mentioned there are 2 number theory questions. However, they are kind of challenging, especially the next one, which is problem number 19. Well, I call these 2 with difficulty 2 because for 23, is that 23? Later we'll mention that interesting question. I call it difficulty 3 stars. And for this one, let's think of that for a moment. In fact, by way of complement, we will see it much more easier. Well, first of all, let's see what does it really mean. Well, a number with how many factors only relate to its prime factorization. So if we have a prime factorization of a number, of course we can count how many different factors, or say how many different positive factors are there. So we have a theorem, we have a formula for that. And also very similar to this, we have a sum of all these positive factors as well. Well, last year we tried to expand that with our AMC 10 course. It is very helpful in terms of number theory analysis. So here we have 2 squared times 5 times 101. And 101, by the way, is a prime. So 3 different prime factors, and we are given 2, 1, 1 with those powers. So apply it to the formula. We have 2 plus 1 with different selections of 2, or say different powers of 2. And then we have 1 plus 1 and 1 plus 1 for 5 and 101. So in all, we have 12 such positive factors. And then how can we think of like all these factors have more than 3 factors? That's the reason I say it's tricky. So for this here, some questions require a bit of turning. So what does it mean? It looks like we write from 1 and then 2, there's no 3, 1, 2, 4, 5, 10, etc. up to 2020. We check for each single factor. Do you have 3 factors? Or do you have more than 3 factors? Do you have more than 3 factors? Do you have more than 3 factors? And then we select all of those answering yes. Can we do that in general? Like, it looks like for 12 we check all of these. Definitely we don't have enough time. We have 40 minutes, we have 25 questions if you do the division. Like I introduced before, on average you will have 96 seconds. Of course, we couldn't have 96 seconds perfectly on each single question. For the first 5 to 10, you're expected, for example, 30 seconds or maybe just 1 minute. And for like the middle 10, you will have around 60 to 70, 80 seconds. And for the last 5, maybe you're expecting 3 to 5 minutes because it requires some kind of thinking and calculation. So we need some steps there. Think of this. If you're given like 1 or 2 minutes for this question, is it possible that for us to check all of these 12? Hard. Really hard. It's also challenging to me as well. So how can we think of this? Again, we need to trace it back to this formula. So if a number as a factor of 2020 has more than 3 factors, that means we want that product. If we want that formula coming out with more than 3, or say at least 4. So now we want to transfer it in terms of at least 4, not greater than 3, more than 3. And if we see that, actually, it gives us weight 2. Why? If we have 2 different prime factors, think of this, at least 1 power for this and at least 1 power for that, then we'll have at least 1 plus 1 times 1 plus 1. So we have at least 4 factors out from there. Is that a magic? So that means any kind of number such that we have at least 2 prime factors will give us the answer. But then, what about those numbers without 2 different prime factors? Well, the good news is that the highest power for a single prime factor is 2. So applying that formula, that means we only have at most 3 factors out from there. For example, think of 2 squared. We have 1, which is 2 to the 0's power. We have 2, which is 2 to the 1st power. And we have 4, which is 2 to the 2nd power. See, there's no other things. So this one gives us a perfect characterization of separation. That if we have a number that has more than 1, has at least 2 prime factors, then we count it. And if it has at most 1, say 1 or 0, which gives us 1, then we throw them away. So how about we consider those we throw away? We know the total number is 12. So for those we threw away, for 5, there's only 1 number, which is 5. And for 101, there's only 1, which is 101. And for 2, we just argued there's 2 and 4. Well, for no such prime factors, there's 1. So 1 is kind of special. Together, we throw away 5 such numbers. Then the answer is 7. Just that. 7. What about V1? Well, V1 follows the straightforward analysis. You will see like we want to characterize all these numbers with at least 2 prime factors, 2 different prime factors. So then we play with all of this kind of combinations. Well, if you can list them all, good for you. Well, I tried it. There we have it. So we have 2 times 5, 2 times 101, etc. all the way up to 5 times 101, of course. You can count all of them. So this is number 17. And what happens to number 19? Well, we will talk about that next time, and definitely it will follow almost the same idea. We need to transfer that to from its original description to something that we can handle. So number theory, again, trace back to what we have, or say what is our algebraic foundation. If you have a very solid algebraic foundation, you will feel number theory sometimes becomes easier, or at least a little, especially for number 19. You will see the play with all these representations. Well, we will mention that on Friday, so follow with us. So if you are having it the first time trying AMC 10, like if you want to take it for the first time, then you can think of register with your school, and if you don't have a chance there, ask us. So we have our QR code on the right upper corner. So scan it. Well, this one is partially locked. You can do it for the next few pages. So what is the difference? What are the differences in between AMC 8 and AMC 10? Although we think of AMC 8 in terms of grade 8 and below, in AMC 10 in terms of grade 10 and below, actually we have a very big jump. So first, for time, we have 40 minutes for AMC 8, and we have 75 as the time restriction for AMC 10. They both have 25 questions, and that's multiple choice 1 out of 5. However, for the pointing system, for the scoring system, we have no penalty for AMC 8, so up to this point, you are still encouraged to make a guess. However, if you make a guess, you don't actually know if you are doing it correct or not. However, for AMC 10, we do have penalty. So if you cannot cross out like 2 or 3 such wrong choices, or is it something that don't make sense, then my suggestion is leave it alone. Don't pick a random guess. You'll have some more points losing. And what about the topics? All AMC 8, if we consider the trend for this year, actually it contains more. Comparing to the past 2 years, or past 3 to 5 years, it becomes more from middle school. However, still it's very few. Like we only have 2 to 3, and of course I trust if you have any idea about letters representing these numbers or defined operations, definitely you shouldn't worry about it. But for AMC 10, it requires a lot from high school, which we will try to introduce and cover with our course. And for the topics and for the way of learning, is that mostly for middle school or elementary school, you will have it from class. And from high school, it requires a lot of self-study. So not only from class. So for our course format as well, it is you to make the decision. So it is self-driven, it is self-motivated, and you will self-teach. For example, for some kind of definitions, my explanation only helps you interpret what is going on. However, every single word makes different sense to everybody. That means you need to interpret by your own. Think of what does it really mean, what belongs to it, what does not belong to it, and what is for example, the opposite of the idea. And what about learning process? Well, if you don't have a chance to scan the QR code, it shows up on every single page. Take out your phone, you can do it now. What is a good learning status? Of course, we need good notes. Here I show an example. Definitely, it is not that neat. It is not that pretty. But trust me, I tried to do it in time. So this is what I had, for example, within 75 minutes to do a problem set. This is just one page. How can I think of this? But at least I can read still from now together with a problem. Like if I take it, the question paper, and then I can recover what is my idea. So sometimes we need some words, where we need some kind of procedures, we need some lines, thinking process to indicate what happens there, especially when you have a calculation-based question. For all these kind of analysis, we do need to point out what is the key point. Well, one of my math professor in college told me, get our hands dirty. What does it mean? You need to write down everything you are thinking. Don't be panicked about wasting paper. Well, definitely we don't need to tear those out or something. But you need to write down every single line, every single idea in your mind. That's how we combine all this together. And also draw everything. Although for AMC contest, we notice that you cannot take your compass or proctors, and you don't have graph papers, but still you should be able to draw something with a rough idea. That requires we need precise, accurate drawing with daily training so that we will have a perfect geometric interpretation. And I put 2 points as my suggestion, my advice for you. Is that algebra is the foundation. Well, we have these 4 topics. We have algebra, we have geometry, we have number theory, and combinatorics, and also those 4 are the topics we have for AMC 10 course as well. Also we have that for AMC TP. So for secondary school topics, those 4 are the major things. Well, algebra is the foundation. Think of this. If we have geometry, we want to prove it, we want to do some calculations, so there are some quantitative analysis. So what is the measure? What is the length? What is that angle? And what is the area? What are the relationship in between? We need to do this computation. And also for number theory, if we want to represent such and such number in this or that structure, how can we do that? And how can we simplify and extract the relation in between? Also for combinatorics, when we count permutation or combination numbers, when we have all these counting principles, how can we manipulate all these numbers with the numbers in the sense literally? We need algebra. So this part is the foundation, and hence we need a very solid base. And we want a very strong foundation. However, in the United States, typically, if you can eyeball it, you will prefer, of course, that is what I was. However, if we make a big step from elementary school or early years for middle school, we want to make a jump into future math study. Get our hands dirty. Take a piece of paper and a pen, write down every single step you're thinking about. And what about geometry? Geometry here also requires a lot of training, a lot of proof. So do some drawing. That is really helpful, not only with a hand drawing. Although sometimes we don't have enough tools in class or in a short time to make it very perfect. But if you have time before the class or after the class, if you're doing it without a timing, like if you're studying the questions themselves, please do with a good construction. So then we will have a very good sense what is going on. For example, we have that sector, we have that semicircle and the square. I believe that is problem 14, probably that. For that kind of things, if we see directly the relation in between the radius and the connection with the midpoint and one of the vertices for the rectangle, then it's done. It's done. So number theory and combinatorics are not that easy for us to prepare ourselves. We're say at least we can train a lot. That's why we need teachers. We need some kind of classifications. We need a summary. However, for these 2, you can start up your preparation, and then you will check with us whether or not we're on the track. Like, are there any areas or regions that we haven't covered? Well, sometimes yes. Okay, so math is fun. Well, before we call it an end for today, I want to introduce something so that we can check for the next time. Well, problem 22, if you remember that weird machine we have that plots, if you input n, and positive integer, then you will have a result back. You will have an output. That one actually refers to a very famous problem, and it is still kind of open. It is not closed. It is not solved by some mathematician. So it is called Collette's conjecture, or a more general name, a 3n plus 1 problem. What does it mean? It means if we input such a positive integer, we follow this procedure. Mathematicians do follow this as well. So if we have even number, we have it, so divided by 2. Or if we have an odd number, multiply by 3 and add 1, and then keep going. So the result, we use that as a next step input, and then we try it again and again and again. So the conjecture first tells us that all positive integers will get back to 1. Or you will say, maybe that's kind of intuitive, but why? We know for even numbers, they're getting smaller. However, if you end up being an odd number that is not equal to 1, it's getting larger dramatically. Multiplying by 3 is not the same level as divided by 2. 3n gets larger, not to mention we have plus 1. So a very interesting question is that, can we have all of these numbers back to 1, and how fast are they? So if you think of this like zigzag issue, the zigzag condition, like once we hit an odd number that is not equal to 1, we have a bump up, and 3 times that plus 1 definitely gives us an even number, and then it starts dropping. So I'll leave that as a little homework for you. So if you want to check it with me on Friday, I'll do that. So if you start with 9, how many steps would you take to reach 1? And also, what about 27? Well, later I'll mention the reason I want to introduce these kind of numbers. And you can do a lot of search. Also, for math learning, our final goal is not just competitions. So we have all these kind of games. For example, I have an extra game for you, which is called Mysterious 6174. Well, that one is even interesting. Well, it's more about calculations. Say if you start with a random 4-digit number, of course, better with kind of distinct digits. So every single digit is kind of different. And then you order all this. So you pick the largest one with a combination, and you pick the smallest one with a combination. You take the difference, and then you follow. Eventually, you will see almost all the 4-digit numbers will end up with 6174. Why I say almost? Is that like if you have 1,000 and you switch, you will have 1, and then you will have 999. So it will end up being a 3-digit number. So it depends on how we define all these numbers. But for most of these numbers, like if we start with 1, 2, 3, 4, something like that, then you will have a output eventually with 6174. Try it. It's a very interesting game. And you can check what happens if we start with a 3-digit number. I'll tell you the answer to that next time. And also, I tried. Well, when I was a middle school student, I tried that with 5-digit numbers and 6-digit numbers and also 7-digit numbers. I like it, although it was kind of crazy. So sometimes it's not just about math competition, but also the way we study math, the way we try to handle all these open questions is that we learn something. We get familiar with all these tools. Well, it's almost the time. Probably I should stop here. It's halftime. Every time we have sports, when we get to the peak, we notice it's almost a time there. So don't worry, we will cover some kind of the challenging questions, what to do next if we want to prepare for AMC 8, AMC 10. Like, what is the general way we learn, we study about mathematics? How about AMC 10? What can we do? Or any other questions, if you like, ask me. We will have a time to discuss about those. So this is the halftime. Thank you everyone for listening, and hope to see you on Friday. It's the same time. All right, for Pacific time? Yes. So if you have a time, you can scan the QR code on the upper right upper corner. We have that. Contact us. Let us know what is your question. What are you going to listen, and what do you want us to tell? That's all for me. Thank you, and bye-bye.